Welcome you all. I'm Dr. C. Janita Nancy, Assistant Professor and Head belonging to the Department of Mathematics, PPG College of Arts and Science, Coimbatore. Today's topic is statistics, the meaning and definition of statistics, scope and limitations, collection of data, presentation of data, and formation of frequency distribution. Meaning and definition of statistics. In plural sense, statistics refers to numerical data itself, which are the facts and figures such as population counts, income levels, or exam scores collected for a specific purpose. In singular sense, statistics refers to the science or method which deals with the discipline concerned with collecting, organizing, analyzing, and interpreting numerical data. There are widely used definitions of statistics, namely by Croxton and Cowden, that it is the collection, presentation, analysis, and interpretation of numerical data. Horace Sechrist says that statistics are aggregates of facts affected by multiple causes, expressed numerically, collected systematically for a predetermined purpose, and placed in relation to each other. In simple working view, we say that the statistics as the branch of applied mathematics dealing with gathering, describing, and drawing conclusions from numerical data. Scope of statistics. Statistics plays an important role in economics and planning, business and industry, medicine and public health, education and research, government and administration, and social sciences. Statistics is both a theoretical discipline and a practical tool applied across nearly every field that deals with numerical data. Limitations of statistics. Statistics studies only quantitative data. Qualities such as honesty or beauty cannot be measured unless first converted into numbers. Results hold true only on average. Conclusions are valid generally and in the long run, not necessarily for every individual case. There is possibility of misuse. Data can be manipulated or misinterpreted by an unskilled or biased user to mislead conclusions. Statistics deal with aggregates, not individuals. Statistical methods describe group behavior. A single isolated figure has little statistical meaning. Statistics is not an exact science. Unlike physical laws, statistical laws are probabilistic and can vary with changing conditions. Statistics requires careful and expert handling. Reliable results depend on sound collection methods and correct application of techniques. Collection of data. The first and most crucial step of any statistical investigation is gathering facts and figures relevant to the problem under study. There are two types of data. One is primary data and other one is secondary data. Primary data is collected first hand directly from the source for the specific purpose of the study at hand. Secondary data is the data which is already collected and processed by someone else, then reused for the present study. Primary data. It is the data which is originally collected first hand specifically for the purpose of the current investigation. Common methods. Direct personal interview. Here, investigator meets respondent face to face. The second one is the indirect oral investigation. Here, the information is gathered from third parties or witnesses. The third one is the questionnaires and schedules. Here, the structured forms are filled by or for respondents. The last one is telephonic or online surveys. Here, the data is gathered remotely via calls or web forms. The merits of primary data: original and reliable, collected for the exact purpose, high accuracy and up-to-date relevance, investigator controls quality and scope. Demerits of primary data: it is time-consuming and often costly to collect. It requires trained staff and careful planning. Secondary data. Here the data are already collected, processed and published by another agency, then reused for a new purpose. Common sources: government publications, journals, books and newspapers, institutional records, and international bodies. Merits of secondary data: it saves considerable time, effort, and cost, and it is useful for large scale or historical comparisons. Demerits of secondary data: may not exactly fit the current study's purpose. Reliability depends on the original source's accuracy. Data may be outdated by the time it is reused. Diagrammatic presentation. Diagrams translate numerical data into visual form for quick and easy comparison at a glance. There are three types of diagrams. One is bar diagram, pie diagram, and pictogram. Graphical presentation. Graphs plot a frequency distribution on axis to reveal its shape, trend, and spread. There are different types of graphical presentations. One is histogram, the other one is frequency polygon, and the final one is ogive, which is known as the cumulative curve. Formation of a frequency distribution. A frequency distribution groups raw data into classes and records how often values fall in each class. There are several steps for the formation of a frequency distribution. The first step is finding the range, which is equal to highest value minus lowest value. The second step is deciding the class intervals. Choose a suitable number of classes, usually 5 to 15. The third step is fix class width, which is equal to range divided by number of classes. The fourth step is tally the data. Record each observation under its class using tally marks. And the final step is counting the frequencies. Total the tallies to get the frequency of each class. Below is an example of marks of 40 students. There are two common types of formation of a frequency distribution. One is exclusive type and the other one is inclusive type. Thank you all for the patient listening.